once we know what the basic versions of the graphs look like, the next thing is to sort of combine this with what we did in section 2.5, which was all the different possible sort of shifts and reflections for our graphs. There are 2.5 videos, so if you want to review how any of those processes go, you can and should do that. We'll do sort of a quick review here for some of them. We're not going to do all the compresses necessarily, but we'll do the shifts left, right, up, and down, and we'll do our reflections over the two axes. But in the context of these exponential graphs. So quick review. If I do f of x plus c, that's going to move my graph up by c units. And what that's going to look like on an exponential graph, the exponential version, right, would be something like y equals b raised to the x, and then you're just adding some number on the end of it, right? So it's f of x itself is our b to the x. We're just doing plus c on the end, which means we just get a plus c. If we do f of x minus c, so that's going to be, I wrote up graph up, that's going to shift the graph up. If I do minus c, that's going to shift our graph down by c units. And what that would look like, so y equals b to the x with some sort of minus c on the end, right? So the addition subtraction is just happening on the very end of the graph after we've like applied the power and gotten our results. Our shifts left and right happen when we add and subtract directly on the x. So if I do f of x plus c, that's going to shift our graph to the left by c units. Where we add and subtract directly on the x's is always a little bit counterintuitive, right? You kind of want it to be that when you add, you're going to move to the right, which is kind of a default positive direction, but it actually is the opposite. The idea is you're sort of adding to your x values, so you're getting to those values faster, which means that your whole timeline gets sort of shifted forward, which to us is going to look like shifting to the left. You're getting places sooner in the timeline. What's this going to look like? So the idea is that it's x plus c in the exponent. So if you're actually adding directly inside the power, right, you're adding to the exponent, that's going to shift us to the left. Obviously then kind of from the other perspective, if I do f of x minus c, that's going to shift our graph to the right by c units. And then that's going to be an x minus c up in the exponent, right, b raised to the x minus c. So those are our shifts left, down, up, right. Not in that order, of course. The two reflections, right, so flipping over the y-axis and the x-axis, those happen when we use negative values. So the two different versions, if we do the negative version of f of x, so I've done the power and I'm just doing a negative version of the result. I'm essentially doing negatives of all my y values. If I do that, that flips me from sort of top to bottom and vice versa. So that's going to be a flip over the x-axis. So we're going to reflect over the x-axis. What would that look like? Well, that's just going to look like y equals, so the negative version of b to the x. So if I just throw a negative in front of it, we always have to sort of watch our order of operations here, right? This doesn't mean a negative b raised to the power. This is b to the x, and then you're doing the negative version of the result. last but not least, for now, if I do a negative inside the parentheses, negative x, so that's going to be reflection over the y axis. So what I'm doing is I'm essentially doing negative versions of all of the x values. So the sort of left and right versions of the graph are going to sort of flip places. So I'm reflecting over the vertical axis, which is the y-axis. What does that look like? So negative x, so b raised to the negative x. This has an interesting connection, right? Because we said in the graphs that we made, 2 to the x versus 1/2 to the x have this kind of a reflection going on. And if you think of, what would 2 to the negative x look like? If you did a 2 to the negative something, you'd get a 1/2, right? You'd take the reciprocal of your base value, 1/2, and sort of raise it to the x, and that's why you'd get that flipped graph. Let's just sort of take a minute and do a couple quick graphs to see what this would look like. Let's see if I can squeeze this in with all these things here. So for example, let's just do a couple quick sketches. And the idea here is that we're not necessarily, yes, who's to say? We're not necessarily going to make a big table for this. We're just going to try to leverage these graphs and sort of leverage these shifts and things to get our results. So let's say we've got y equals, let's do 3 to the x minus 2, and then let's subtract 4. So what kind of moves is that going to mean? Well, so x minus 2, this is x minus 2, right, in the exponent, so we're subtracting directly from the x. So that's going to mean a shift to the right by 2. And then we have minus 4 out here on the end of it, right? If we subtract by 4 on the end of it, that's going to shift us down by 4. So if I made a quick sketch, right, again, not being so particular about all these things, what's this going to look like? Two, 3, 4 is there, maybe. So part of this, if I'm shifting down by 4, that means my asymptote, my horizontal asymptote, is going to happen at y equals 4. So y equals 4 as my asymptote. Instead of going through 0, 1, I'm shifting down by 4. 1, 2, 3, 4. I'm also shifting to the right by 2. So what's happening here, if that used to be 0, 1, and then I'd be sort of creeping down towards the asymptote from there, I can start to draw that in, something kind of like this. This, in theory, right, is obviously continuing and getting closer and closer and closer. From there, I'm going sort of up and to the right. What would be another value here? When x is 1, in theory, you'd be at sort of 1, 3 for 3 to the x. So now you're going kind of 1, 2 over, and then you're going down 1, 2, 3, 4. So you'd be somewhere here. So in theory, what's happening is our graph is going up and to the right from there. So our asymptote is here. We've shifted right 2 to the right, and we've shifted down by 4. And that's going to be our graph. That's going to be roughly what we're working with. I'm going to tempt fate and try to sneak another one down here in the corner. Is this a great idea? It's an idea. I'll say that much. Let's throw caution to the wind and try again. Let's do y equals, let's do -2 2 to the x plus 1. So something a little bit simpler. This is a negative in front of the graph, so that's going to be a reflect. Oops. Which was that for us, right? Reflect over the x-axis. Right, which means we're sort of flipping top to bottom rather than left to right. And then x plus 1 means that we're going to shift left by 1. So let's see if we can make this happen. Again, we're trying to kind of do this without necessarily making a new table of values. That is always an option. We're not necessarily trying to do that. We're trying to just make kind of a quick back of the napkin style sketch here. So what are we working with? Let's start with that 0, 1. That's a really nice standard point. Let's flip it and let's shift it. So 0, 1, we're sort of reflecting over the axis, so that's going to take us down here, and then we're going left by 1 to here. We're not moving up and down, so our asymptote is going to remain at 0. And so in theory, what should be happening here is, right, normally my graph is coming down to the left, up and to the right. If I flipped it top to bottom, I'm going to be coming sort of up towards 0. And then my exponential growth is now flipped. Instead of going up and to the right, it's going down and to the right. So a coordinate like, what would our next point be? Maybe like 1, 2. So we're flipping that to here, and then 1 to the left. So maybe our growth portion looks something kind of like that. So we're going down and to the right, and then sort of up towards this. The whole thing is shifted just sort of 1 to the left. If you want to, Desmos is a great tool, right? That desmos.com website is a great tool to just sort of play around and just like make some graphs and just sort of play a little bit either with the base values, play with sort of adding, subtracting to do these shifts up, down, left, right, throw these negatives in, take them out. Doing that kind of stuff is good, and I think is sort of useful just to get a sense for what's going on. That's the basics of it. So doing these shifts on our exponentials goes like that.